Hi, my name is Mark Manuel, and I'm an electrical engineering student. This is an instructional video on introductory soldering techniques. You're going to want to start off with a 60-40 lead to silver ratio. Leaded solder is a lot easier to use than lead-free solder, and you should shoot for a thinner solder around 31 millimeters. If this is your first soldering iron, you're going to want around 40 to 50 watts and stick with the most popular and trusted brands like Weller, Hayco, or Metcal. For through-hole components in this video, you're going to want to use a 16th inch screwdriver tip. If your iron has variable temperature, you should set it to these following temperatures. Lead-free solder has a higher melting point, so it needs a higher tip temperature. If your iron didn't already come with it, you should have a tip cleaner for excess solder and tip tinning. You need solder wick or solder remover if you mess up. A third hand tool is helpful for keeping your circuit boards and wires in place when soldering. You're going to need micro shears to cut off the component leads, and alcohol or an anti-static brush and Q-tips to clean off the flux residue. You're going to tin the tip of your soldering iron before you start soldering, after every few leads, and before you turn off your soldering iron. Start by bending your resistor leads by 90-degree angles. Place the resistor in the circuit board and secure it down with tape so it can be flush with the board. Now you're ready to start soldering. Contact both the pad and the lead with the soldering iron tip. Next, you should feed solder on the opposite end until it gives a conical shape. Stop feeding solder and remove the tip in that order. The soldering iron should leave last. One thing you should never do is to accumulate a large amount of solder on your tip and spread it onto the lead. This doesn't work because neither the lead or the pad get hot enough for adhesion. It worked out in this lead, however, later in the video you'll see an example where it fails. Trim the leads one at a time to prevent strain on the board. Pins on ICs can sometimes be too wide. You can bend them on a flat surface, like a table. You can also use a tape trick to keep ICs in place and flush with the board. This is a case where the lead wasn't given enough solder, so it doesn't have that concave geometry to show that it was wet properly. In this example, we're going to use bad technique to show what a cold solder joint is and how we can fix it. Those two joints have too much solder and they're not wet properly. You have to rework them by removing the solder with a solder wick. Just like how paper towels suck up water, solder wick sucks up solder in liquid form. Because you need all the solder in liquid form, you're going to try to maximize the heat transfer by laying the soldering tip flat to the wick. You might not be able to get all the solder in one go, so you're going to have to repeat the process until it's fully clean. Lastly, you should inspect your work. Both components should be flush with the board, and the solder should be flowing up to the leads of the component. You can see where we didn't have enough solder in the previous example. And that's it. You should tin your tip before you turn off your iron. As you can see, soldering isn't so difficult at all, but there's a few things that you should stress. One being safety. The soldering tip is going to be at around 600 to 700 degrees, and this is more than enough to burn insulation and also your skin. And flux can cause asthma over time, so you want to work in a well-ventilated area. As for soldering, you want to make sure both the pad and the lead are hot, as solder can adhere to cold surfaces. And lastly, your solder joints should look concave and smooth. Anything otherwise may indicate that you have a cold joint.